Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science Engineering in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about graph theory. So very first thing is that graph theory in the study we're going to see about the points and lines. So in particular, it involves the ways in which the sets of points called vertices that can be connected by lines and edges. And graph theory has proven usually in the design of integrated circuits for computers and other electronic devices. So the graph theory was invented by Euler. So graph theory is the study of points and lines. Mainly this one is going to be used in which the sets called vertices and which is going to be connected by lines called edges. So the graph theory has proven useful in the design of integrated circuits and computers other than electronic devices. So this one invented by Euler here. So, so the graph is going to have collection of nodes, what we call it as vertices, and this one what we call it as edges here. So graph is an ordered pair which is going to be represented as G is equal to V of E, comprising a set of vertices and nodes and points together with a set of edges and arcs or lines, so in which the two elements sets subsets of it. And edge is going to be associated with the two vertices, and the association takes of the form of another pair of vertices. And this graph may be a directed one or indirected, weighted graph or underweighted graph. A graph may be with self loop or self edge, we call self edges graph. So graph is nothing but its ordered pair comprising of set of vertices, nodes or points together with set of edges, arcs and lines which are two element subsets of V. An edge is associated with two vertices and the association takes will be of the form of another pair of vertices. So these edges can be have either directed one or indirect one. So this should be the directed edges. And the graph which is not going to have any type of directions, so that should be called as undirected edges. And suppose if I'm going to assign the weights along the wedges, then it should be treated as directed graph, weighted directed graph. And similarly, if I'm going to assign some weights here, that should be weighted undirected graph. So graph with self loop or edges, what we call it as uh, uh, simple graph. So if you look at this, these are the different types of graphs. So these are the nodes of the graph, what we call it as vertices, and the line that is connecting the two vertices, what we call it as edges here. So this one should be the directed, undirected graph. Similarly, undirected graph, if I'm going to assign the weights here, so then it should be treated as weighted graph. Similarly, directed graph means we're going to assign some directions along the edges, then it should be treated as the directed graph. Similarly, if I'm going to assign the weights along this graph, then it should be treated as weighted directed graph. So, and then a graph with self loop here. So this is the graph. So in this graph, if I'm going to assign a loop, so this one with what we call it as graph with self loop. So types of graphs, so there will be different types of graphs, what we call it as null graph, a graph which contains only isolated nodes. So that is set of edges of the graph, what we call it as null graph. And regular graph means a graph in which each vertex has same number of neighbors is called regular graph. A regular graph with vertices of the degree called k regular graph and regular graph of degree k. So the complete graph is a graph in which each pair of vertices is joined by an edge, and complete graph contain all possible edges. So the types of graphs here. So null graph, a graph which contains only the isolated nodes. So that should be treated as null graph. That means a graph does not have any set of edges. So this one will be called as null graph. And regular graph, it means that which is going in which each vertex has same number of neighbors. And that means each vertex has same degree. Suppose what is the degree of this node? That should be 2. This degree is 2, and this one is 2. So the graph which is have whose vertex is going to have same degree and then same number of neighbors, then should that kind of graph what we called as regular graph. A regular graph with the vertices of degree k is called a k-regular graph or a regular graph of degree k. Then what is the complete graph here? A complete graph is a graph in which each pair of vertices is joined by an edge. So a complete graph contains all possible edges. So this is not a complete graph. So if a complete graph means each pair of vertices is joined by an edge. So this is also a graph, but this should not be treated as a complete graph. So if I'm going to join this one also, then it should be treated as a complete graph. A complete graph should also be have a regular graph as well, but a regular graph cannot be a complete graph. Next one, bipartite graph. So what is bipartite graph? So a bipartite graph is means in which each vertex can be partitioned into two sets so that no two vertices share the common edge and no two vertices in X should have share the common edge. So the chromatic number of bipartite graph is 2 here. So normally this bipartite graph is the one vertex can be partitioned into two sets, so W and X, so that in the no two vertices in W share a common edge, and similarly no two vertices in X should share a common edge here. So normally the chromatic number of this graph is 2 normally. And what is this complete bipartite graph here? So in this complete bipartite graphs, the vertex set is the union set of two disjoint sets, so that every vertex in W is adjacent to every vertex in X, but there is no edges between W and X. In complete bipartite graph, so the vertex is the union of two disjoint sets, so that every vertex in W is adjacent to every vertex in X. So example of types of graphs. So this is the graph which is have individual vertices, but that does not have any edges connecting between them. So this is called as null graph with the three vertices. And next one is complete graph with three vertices. So here, so this is the nodes, and each and every graph is going to be connected by an edge. So this should be the complete graph. And regular graph means that, so here each and every vertex will have the same degree, right? So this should be a regular graph, but this should not be a complete graph because these edges are not connected. So since this should be a regular graph only. And bipartite graph means, so this should be the example of bipartite graph. And complete bipartite graph means, so each and every edge is connected to the uh, remaining vertices. Then representation of a graph. So a graph can be represented in two ways. So first one is adjacency matrix and second one is adjacency list. So adjacency matrix is a 2D array of size V by V, where V should be the number of vertices in the graph. Let 2D array be an adjacent and slot adjacent to 1. So indicate that there is an edge from vertex I to vertex J. So the adjacency matrix of undirected graph is always symmetric, and adjacency matrix is also used to represent the weighted graph. And so if edge I j equal to W, then there is an edge from vertex I to vertex J with weighted W. So here, so adjacency matrix means, suppose if I'm going to have a a graph like this v1, v2, v3 and v4. So how can able to represent adjacency matrix here is that, so take set of vertices row wise and then column wise. So there is an edge from v1 to v2, so and v1 to v3, and if I'm going to take v2 to v1, v2 to v4, so v1 to v2, v3, v2 to v1, v4, v3 to v1, v4, v2, v3. So like this, we are going to represent the adjacency matrix of the given graph. Similarly, adjacency list means how we are going to represent here is, so we are going to have a set of vertices, so v1, v2, v3 and v4. So for this v1, so we are going to have v2 and then v3. So for this v2, I am going to have v1 and then v4. So like this, we are going to represent the adjacency list of the given matrix. So adjacency list means it should be an array of lists that is going to be used here. The size of an array is equal to the number of vertices, and let array be represented as this one. And entry of array I represent the list of vertices adjacent to vertex I. So this is the representation that is used to represent the weighted graph here. And the weight of edges can be represented as a list of pairs. So adjacency list means it should be a size of array, and it should be represented in the form of list. So mainly this one is going to be used if I'm going to represent the weighted graph. So the weights of edges can be represented as a list of pairs. So example of adjacency matrix. So this is the matrix I'm going. This is the graph that is given. So three vertices. So I'm going to take it as 1, 2, 3 here. So 1, 2, 3. So I'm going to represent. So there is no vertex from 1 to 1. So 0. So then 1 to 2. So I'm representing as 1. And 1 to C is there. So 1 to 3. And similarly from 2 to 2 to 1 and then 2 to C. That means 2 to 3. So 1 and 1. So remaining all should be 0. And from 3 I'm going to have 3 to 1 and then 3 to 2. So that's why this should be 1 and this should be 0 here. So this is the way of representing a graph in using adjacency matrix. Similarly here adjacency list means that, so we are going to have a header node. So from this header node, so that is 1 here, they should be connected 2 and 3, and from 2 it should be 1 and then 3, and from 3 it should be 1 and then 2. So this is the way of representing the adjacency list of the matrix. So graph algorithms. So some of the basic graph algorithms will be DFS, DFS, shortest path and distress algorithm. So DFS means depth first search. So this is one of the kind of traversing technique. So traversing means that, so visiting all the nodes of the graph exactly once. And these two should be the traversing techniques, what we call as DFS and BFS. And this is the algorithm that is used to find the shortest path on the graph, and distress is also an algorithm for finding the shortest path. And next one is graph coloring. So graph coloring is the method to assign the colors to the vertex of the graph. So that the no two adjacent vertex should have same color. So if I'm going to consider a graph here, so the graph coloring means if I'm going to assign color blue here, they should be red. No two vertices should have the same color. And similarly, I can able to assign. So the chromatic number is 3. So some of the sample graph coloring problems will be vertex coloring, edge coloring, and then face coloring. So vertex coloring means it should be a way of coloring the vertices of the graph so that no two adjacent vertex should share the common color. And edge coloring is the method of assigning colors to edge such that no two adjacent edges have the same color. And face coloring means it is assigning the color to the face or the region of the planar graph so that no two faces share the common boundary have the same number. And chromatic number means that this is the minimum number of the colors that are required to color a graph. This should be the concept of graph coloring. So graph coloring means it is the method to assign the colors of the vertices of the graph such that no two adjacent vertices have the same color. And some of the graph coloring problems will be vertex coloring, edge coloring, and then face coloring. So edges vertex color means, so this is the example. So the no two vertices going to have the same color. Similarly, the no two edges should share the common color. And face coloring means the region of the graph that is going to be uh, colored should not share the common boundary. And chromatic number means this is the minimum number of colors that are required to be color the graph. So that should be about the graphs here. So graph theory is the study of points and lines, and it should be useful in designing of circuits of the computers and other electronic devices, mainly invented by Euler. And the graph is nothing but ordered pair, which should be represented in the form of vertices and then edges, and each edge is going to be associated with the two vertices. And graphs may be of different types like directed, undirected, weighted, and unweighted. And a graph may be have self loop or self edge also. So these are the representations of the graph. And what is a null graph? So null graph is one of the type that means it should have only the isolated nodes. And regular graph is the graph in which the each vertex have same number of neighbors, what we call it as regular graph. And complete graph is the graph in which each pair of vertices is joined by an edge, and a complete graph contains all possible edges to the vertices. And biparty and complete biparty graph. So biparty graph is the graph in which the vertex set can be partitioned into two sets so that no two vertices of these two sets share the common edge. And complete biparty means that, so here the vertex set should be the union of two disjoint sets such that every vertex in one W is adjacent to every vertex in X. So these are the various examples of graph. So null graph, complete graph, regular graph, and biparty graph. And representation of the graph. These are two ways of representing the graph. First one is adjacency matrix and adjacency list. So adjacency matrix is the 2D array of 2 by 2 or 3 by 3 matrix form. So it should be represented here. And mainly this adjacency matrix is used for representing undirected graph, and it should also be used to represent the weighted graph as well. And adjacency list means here it should be a single dimensional array. So mainly this one is going to be used to represent the weighted graph. And this is the way of representing this adjacency matrix representation and adjacency list representation of the graph. And graph algorithms, what we are going to have is depth first search and breadth first search. So these two are the two traversing techniques. So for to visit all the vertices of the graph, and shortest path problem and distance algorithm. So these two are the two algorithms for finding the shortest path of the graph. So example like traveling salesman, TSP problem, salesman problem is one of the best example to find the shortest path, and then distress algorithm. And graph coloring is the method to assign the colors of vertices of the graph such that no two adjacent vertices have shared the common color. And Vertex coloring. So way of coloring the vertices of the graph so that no two vertices share the common color. And edge coloring means this is the method of assigning color to each edge so that no two adjacents have the same color. And face coloring means it assigns a color to each face or region such that no two faces should share the common boundary. And chromatic number is the number of colors that are required to color the graph. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.